So now we're going to make the computations to test whether the mean sales for the 4 different locations are all the same or not using the ANOVA approach, analysis of variance. So we need to first gather some sample statistics from the sample observations given. We need the sample sizes, which will be count. Okay. Sample mean will be the average. Then we need the sample standard deviation. So STDEV dot S, that's our standard deviation. Okay. Now we copy that across. So we have the information for all the 4 different samples. Okay. Now overall mean, if the sample sizes are all the same, we can simply average the sample means. But if the sample sizes are not the same, then you have to go back to the original data and average them all. So if you do average all of them, then we get the overall mean of X double bar. Okay. Now N is the overall sample size, all the samples put together. So if you do a sum of the sample sizes, you'll get the overall sample size. And C here is 4, and I'll use a function for that, count A, because this is non-numeric, so we have to use count A. Okay, so now we have all the necessary sample statistics here. So now we can apply the formulas to find the sum of squares. So sum of squares among groups SSA is this. Okay. Now I'm going to do this for each individual sample and then add them all up. So the SSA preliminary computations are each sample size n times sample mean X bar minus X double bar. Now remember, X double bar must always come from C38. So I'm going to press the function for F4 key to insert the dollar signs. So C38 will become an absolute cell reference. So copy process will not change the cell reference from C38 to D38 or something like that. Okay. Now I have to square that. So n sub 1 in this case times X bar sub 1 minus X double bar squared. Okay. Now if I copy that across, I get the different contributions or different terms for each of the j values going from 1 through C. SSA then is the sum of all of that. So that will give us the sum of squares among groups. Now sum of squares within groups. Okay, so here is the formula for that. So this is the original formula and this is a modified formula which is easier to apply. So for each sample we have to go n sub j minus 1 and then multiply that with the variance of that sample. So variance, remember that. Now we go n sub 1 minus 1, okay, times the standard deviation and square that. Okay, we copy that the rest of the way, so you will get that computation for each of the 4 samples and you add them all, you get SSW. Okay. SST is the sum of the 2. If you sum SSA and SSW, that will give you SST. Now we can organize all of this information into the ANOVA table, and you have to understand how the ANOVA table is set up. So when you're given partial ANOVA table, you should be able to figure out the rest of them. So here, sum of squares treatment is among groups. So the terminology is also, you should get familiarized with this. Okay, different textbook and different software packages use different terminologies. Treatment is the same as among groups. SSA is treatment. And then error or residual, in this case, is SSW. So this is that. So here treatments is your SSA, error is your SSW. Okay. Now degrees of freedom is what? C minus 1 for SSA, it will be C minus 1, and then N minus C for error. For total, it is N minus 1, which will be the sum of these two. So here the total is the sum of those two. Now mean square is always, okay, here is something that will come again and again in different chapters. Mean square is always sum of squares divided by the corresponding degrees of freedom. So it will be, you take the sum of squares, you divide by the degrees of freedom. So that will give you the mean square. So this is mean square A, MSA, or you can also call it mean square treatment. If you copy that, do the same thing for this row, you get MSE, or mean square error, or mean square within groups. When you find the ratio of these two, that's your F statistic. Now the p-value is f.dist.rt. So the right side tail value, it's a one tail test. So you take the F statistic and then the two degrees of freedom. The numerator degrees of freedom and the denominator degrees of freedom. So that will give you the p-value. And this is in scientific notation right now. So you can change it to percentage notation. And you see the p-value is really close to 0. This does not mean p-value is equal to 0. Instead, p-value can never be equal to 0, which would mean certainty. In statistics, you don't have certainty. Okay. So this is the basic computation. Now we have to use these computations to complete the test. So we'll look at that in the next video. Now we have the ANOVA table prepared from the previous video. Now we want to use this information to test the hypothesis stated here. All the means are same, not all of them are same. Alpha is 0.05 or 5%. So first thing is, what are the assumptions required? So let's look at the assumptions in general terms, and there are three assumptions stated here. Okay, the samples are taken from each level of the treatment factor are random and independent. So random, independent, random samples from the different groups. Okay, so that's first. Then the response variable follows normal distribution for each of these different samples. And then the third is the variances are all equal for the different populations or different treatment levels. So these are the three assumptions in general terms. Now how do you state these assumptions for this particular case of mobile electronic sales for the four different location possibilities? So the first assumption then is samples of sales taken from each placement location are random and independent. Okay. So in other words, the samples taken from the different stores are all independent random samples. Sales for each of the placement locations follows normal distribution. So that's the normal distribution assumption, the second one. The third one is that the variance of sales for those different placement locations, they're all equal. Okay. Now based on these assumptions, then we can set up an F critical value using the F table. So we have F dot INV dot RT with alpha given here 5%, numerator degrees of freedom, comma denominator degrees of freedom. So that will give us the F table value. Then we compare that against the F stat value, which is 88.22, and therefore we reject the null hypothesis. So the conclusion is, so F stat is greater than F table, so we reject. Now we can use the p-value approach as well. So it should be F dot dis dot RT. Now we use the F stat first and then the 2 degrees of freedoms. So this will give us the p-value. So p-value is less than 5%, so we reject the null hypothesis. So the interpretation now is, so we do have sufficient sample evidence to conclude that the average mobile electronic sales for the different placement locations are not all the same. The probability that this conclusion is wrong, which is type 1 error, is nearly 0. Don't say 0 because p-value can never be 0. So this here it says is very small, close to 0, so it is nearly 0. So this is the ANOVA test. Okay, look at the underlying concepts, the assumptions needed, the sample statistics, how to compute the sample statistics, and then the F critical value or p value, and then do arrive at a conclusion and interpret the conclusion.